Yeah, okay. So, on a normal weekend, what time is it now? It's 8:30. On a normal weekend, I would not have kept working on this at this point in time, after all the time I've spent on it already. But I really want to finish this. I almost never finish anything. In fact, I can't remember the last time I finished anything, except for like at work. And I think I want to push through, put in the junctions, because that is the last difficult thing to implement. Well, the delay stages may be difficult to implement. But no, anyway, let's just work on the junctions. So I was thinking to myself earlier, the way that gates work is we have a place gate, we have an erase gate, and we no, actually, I was about to say it might be possible to cast the junctions and the gates into the same kind of like container object and do some kind of fancy stuff there with like having function pointers in the objects, or I guess you'd call it a function reference in Lua. And that might be nice, but honestly, I don't really see it helping. It might help if casting it into that would like make uniform the code for junctions, delay stages, nets, gates. But honestly, like, how helpful really would it be? I mean, once I add those 4 things and maybe a few other little things here and there, like, you know, the game's done. Like, I won't be adding any more. This isn't like Terraria where there's like updates for like 20 years or whatever. It's just like at some point I'm going to say it's done and stop touching it. So yeah, I don't really need to worry about casting it into like the fancy object-oriented form. Anyway, let's first start with place junction. So I guess I'll put it at the bottom. Now, let's just take a quick look at place gate for a little bit of inspiration. Yeah, we can take this. Okay. So the connections between the gate and the junction are going to be use the kind of the exact same logic, where the junction has 4 port objects on it, and you don't connect automatically. You have to manually like wire into the junction. Yeah. So what else do we have in here? Erase what was here before. Now here, I figure out what gate it is. In my case, I will need to get the actual type of junction being placed. So let's go in here. Where is that? Gate junction. Now up here where we have G cell X and G cell Y and G menu, we are also going to want for junctions. We'll have, I guess, T cell X. There's really only 2, right? There's just a flyover and a budding. Abutting doesn't really add anything. It just, like, in other words, flyover junctions actually make things possible that are currently impossible. But the abutting junctions don't really, like, give you any new capabilities. It's just for convenience. It just lets you make some, like, smaller designs. Yeah, anyway. So I'm just going to say t_select equals 1, t menu equals false. Here's another thought. Maybe the way you place junctions is actually automatic, or it's like a mode that you set. So normally if you draw a wire and it touches another wire, it'll automatically merge them. But I can make it so that instead of automatically merging them, it'll create a flyover junction. Well, is manually placing junctions like really that difficult? I mean, it would be annoying if you had to place like 8 in a row, but that could be made easier if we have a copy and paste kind of system. All right, yeah, let's do, well, now I'm hesitating again. Like, if we, if we do the mode bit way, how would the user control the mode? Would we make a menu item for them to edit in the pause menu? I don't really like that. Maybe it would be a tool, like config. So as you're scrolling through the tools, you would scroll through config. I don't really like that either. What if we put the junctions in the gate menu? That might not be a bad idea. You know what? I think I like that. I think I like that, having the junctions in the gate menu. And in the future, we can put other stuff in the gate menu. So it's not so much gates as it is components. because I'll put delays in there. And yeah. Yeah, okay. Let's do that. So I guess this is another case here where something was originally called G and then it was expanded to mean more than just that. Order for drawing gates also serves to map from, I guess I should say G cell. This is now components. So on the next row we would have, I guess we'll take 5 and 9. And although they're not ready yet, well, since they're not ready, let's just not bother to put them in. I am going to pad this with zeros. And then let's go here into the drawing and in draw gate menu. This is now, well, I'll just leave it as G for component. So we got that. TLY. So the height is now 10 more than that. So 52. Okay, let's take a look at what that looks like. Yeah, okay. Now we can't select them right now because I need to edit that. Let's just see what it looks like everywhere else. Yeah, I think this is fine. Yeah, it's actually really, for some reason, really like almost infuriating that I can't select it. So, what's the difference between a gate and a junction? Well, the gate has its T off variable, and it has just one state. On the other hand, a junction also has a T off, but it has 2 states. And the delay has like a history of like saved stuff. It has its current state as well of whether or not it's latched and what its output is. And it also has 4 ports. So yeah, all components have this 4 ports thing in common. There's got to be a way to like streamline the code a little bit, so I don't need to have so many special cases for each type. Well, anyway, let's go back in here and edit the gcell function here. So gcell 5. If, I mean, this is like ugly corner case, so we can't make invalid selections. Gcell y equals 5. Then gcell x equals max of, min of gcell x into 2. All right, let's see what that gives us. So if I go down here, everything's fine, and if I go down here, it warps me to that one, warps me to that one. Yeah. Now, if I don't know what'll happen if I press X here. Yeah, something went wrong. Attempt to concatenate field state and nil value. Yeah, like, yeah. So what we need now is down here when we're in the component mode. So instead of place gate, what we need is place component. And what we'll do in here is we need a new function, place component. I don't know if I'll keep this place junction, but we'll see. Place component. Now, all right, let's think about this here for a second. What would I change to this function? Like, can I change this function to have if defs and stuff? Or not if defs, rather, but if the type is gate, do this. If the type is junction, do that. So this would change. This would change. This would become unnecessary. So the creation of a new object, like the construction of a new object here, would be completely different, pretty much. Although the creation of the ports would be identical. Here, if the port is a component type, I don't mind having a bunch of words in here, that's not a big deal, then we'll automatically connect it. This would be the same for both. Here we would add 2 junctions instead of 2 gates, but maybe we should just have a list of components. Yeah. So like, yeah. Yeah, I mean, I'll just leave it as gates. I really don't want to rename it. All right, let's get rid of this big comment. It's just getting in the way, and I'll just put it in notes. And some of this stuff is out of date now. Let's call this notes. Big comment that used to be tab 1. Bam. that in there. Let's do a little bit of cleanup around here. Default grade object acts as a sentinel, so we can avoid explicit nil checks. And by the way, let's also do state equals 0. Blank state equals 0. Okay. This is just for some debug stuff. Now here we have that. Now instead of junctions, actually we just have gates. Includes all components. Lookup tile number given a binary state of cardinal directions. Am I even using this anywhere? Used to draw wires based on neighboring. Oh yeah, I am using that actually. But this neighbor's P is definitely not being used. I use this penum lut for that, which is very similar. This neighbor's W, I use it only in one place. This is fine. This is fine. This is fine. State vars for component menu. This is written in the notes, so I don't need to have it here. Vars for dealing with cursor movement. Yeah. This is a weird way to do it, but whatever, it's fine. Okay. Compute states for all nets, so we draw them correctly. For all nets, reset the state. We should do this for components too, or for junctions, I should say. Actually, no, so for each junction that we draw, we will just check its neighbors. The gate is a little bit different because it's a storage element, but the junction is combinational, or well, I'll say it this way, it's instant. So the junction will just check its neighbors at the time that we draw it. Oh, but wait, that doesn't work. Like, what if I had like a whole big grid of junctions? I would end up doing like a sort of a depth first search. Although, I guess for each junction, it'll be inside the components list of another net, which means it can point to the nets that it's connected to. In fact, I think it should. But it's the ports that point to the nets. The thing is that a port can point to a junction. Yeah, I think we don't have a choice here. I think after we do all this, we then go back into the nets and just drive all the junctions. In which case it is this is really fiddly. I mean, I could write some spaghetti code to do it, but I'm really struggling to keep it clean. I mean, it's already, like, this code is not bad, I would say, but I've certainly done better. Yeah. All right. Let's keep trying to clean some of this up here a little bit. This isn't comparators, it's components. This test DFS code doesn't even work anymore, and if I really want it, well, fine, we can put it in really old stuff. Save it for as long as I can, but I'll get rid of it at some point. I'm not really using this anymore, it's just cluttering. Okay. Shoot. I wasn't thinking. But I forgot to commit to git. Well, did I forget? You can't see my git window, can you? I did commit. Okay. Well, actually, no, I didn't. Oh my goodness, there's a lot of changes. Okay, now I didn't commit like that stable version from earlier today when I stopped. So I guess I'll try to make sure this is stable before I'm done for tonight. It's 9 o'clock. I shouldn't stay up too much later. Now this is where, actually I probably will need this when I'm debugging junctions later. We need to deal with components. But this would work for junctions too, I think. Yeah, this would work for just general components. I may in the future add like a boolean that says is component or something, but this will be good enough for now. And yeah, this checking post condition here, I'll just hang on to that. This is pretty clean. Well, I mean, when I say clean, you know, I really don't need this anymore. I'm not using that at all. It's pretty much fine. So let me put this in my usual style. What else? Yeah. Okay. So I was just looking through this place gate here, and I'm thinking to myself, the differences between this and place junction are fairly minor. I mean, here we would change the type. Here, instead of, so here I distinguish between different kinds of gates by using T off, and I pre-compute this love base, which is basically the same as T off, just with a bit of math on it. These two things that distinguish the gate type from within the list of all gates, I suppose look a little different for distinguishing the junction type from among all the different types of junctions, but it may be nice if we could, you know, you know what? For now, let's just try and keep this in a stable state here. Go in here because, like, there's a reason why I wouldn't normally have continued working on it, because like I feel really tired and unfocused. It's not really a good sign. But here, let's just put this back to 4. I mean, it'll draw the extra stuff, but you won't be able to select it, so you won't be able to do anything bad. Uh-oh. Oh yeah, we're calling place component now, but I'll just put this back into place gate for the time being. Put a little to do. So you can't select them. Oh, I happen to have picked. Yeah, so now we have a nice little oscillator there. Nice and easy on the eyes. And we can scroll the screen. It would be nice if maybe there was a way to tell where you were, but whatever. Okay, so at least we have it stable, which is, I should have pushed before I started changing these other things, but get status, yeah, dash u, get commit dash m, commit a mostly stable version before big changes to support junctions. So, I'm really finding it hard to actually think. In the other streams I was doing earlier, you'll just have to take my word for it, but when I was silent, I was actually thinking. Now when I'm silent, I'm not thinking because I'm too tired. I really probably should not have even started doing this. I think I need to stop. Okay, let's at least work out like some more details about junctions. I'll just put them kind of randomly here. try to rewrite place gate as place component that uses gcellxy to know if gate junction other I really need to figure out when doing driver phase of simulation, how do we update the junction objects? OBJs. That I'm not sure about. One idea is we'll just iterate through the nets again, go through the list of all of their connected components, and just if they happen to be junctions, then figure out what state within the junction gets targeted by this net and update it accordingly. And like, yeah, that's fine. But, you know, we'll be iterating through a lot of stuff multiple times. We can make it a little bit better if we keep the gates and junctions separate as separate lists inside of the net object. But then we're breaking uniformity, which I don't particularly like. But on the other hand, like, it's just not uniform in the first place. Like, I specifically want that junctions don't break nets. Like, if two halves of the net are connected through a junction, it should just be treated as one net. And the reason is because it prevents us having to do DFS when we're simulating. Like, we always have to do DFS when we are like editing the nets and drawing and erasing wires. Like, there's just no way around that. But when we're simulating, we really don't want to do that on every net object. And the other, so another big question here is, how do we manage the link from junctions to and from nets? Now we can do this with gates. A gate can have a list of nets that plug into it. There's no point because we never use that information for anything. On the other hand, each port has a neighbor. And the thing is, it's not enough really for within a junction each port to point to a neighbor. And the reason is because like, you could have a whole big grid of junctions and end up like, how do you know what net a junction is connected to? Well, if all you had was the information of the neighbors of each of the ports, you would have to do a DFS or, well, some kind of graph search to find out what net it ultimately connects to. On the other hand, if every junction object within like the parent object, not within one of the 4 port child objects, if within the junction object we made a we kept a net pointer, right? Well, then that would be that. We would just have to be careful to maintain it as we draw wires and erase wires. But yeah. Man, the junctions are really challenging. Not from like a fundamental like concept point of view, but more from just like trying to keep the code clean and usable. Because don't forget, I still have to implement delays after this. Maybe if I think about how delays would be implemented, it would kind of guide how to do not just the junctions, but even maybe how to improve the gates. So for delays, what is the difference between delays and gates? Actually, very, very little, because delays will split nets. It's really just junctions that are a special case. Like, oh wait, no, I'll put it this way. Any delay element will split nets, because it has to. There's no choice. Any pass-through element, shouldn't. So like junctions are the only pass-through element that I have right now. I did have an idea of having multiple layers, so there could be other pass-through elements that would be like vias, basically, to connect up to the other layers, but okay. I think now that I've thought about how delays and gates really are like peas in a pod, I now see that I'm just trying too hard to try and make the code uniform between gates and junctions, because they're fundamentally different. Junctions are fundamentally like zero delay. They don't split nets, whereas all the other components do. Even if they are combinational, like even if we decide one day to add like a zero delay not gate, because right now the only not gates are like one delay not gates. But even if we had a zero delay not gate, for example, or any other zero delay gate, it'll still split nets, right? So the junctions really are special. So yeah, I think I was just trying too hard to keep the code uniform. It would make more sense, instead of trying to make the code for junctions be more uniform with the code for gates, it might make more sense to try and make it more uniform with the code for nets. But the net code is really thorny, and I really don't want to add more complication to it. I'd rather just try and keep the code paths for junctions separate, because they still share a lot of things with gates in the fact that they have multiple ports. Whereas with nets, we kind of don't do that. We just check the neighbors and automatically figure out what tile to draw. Anyway, now I'm just babbling. Is this even working? Oh yeah, okay. Yeah, no. We will keep junctions as separate. So with all of that in mind, I think my original plan is the most workable. I don't see a cleaner way around it. We will carefully maintain links from every junction element to the net that drives it. To be precise, every junction element has two nets that drive it, which may actually be the same. So we'll have to make sure to understand that case as well. But so yeah, every junction element has two pointers that point to nets, and then every net should have junction pointers, and we'll keep them separate from gates. I think for the case of the user interface, putting the junctions in the component menu makes a lot of sense. But from the point of view of the code, treating junctions the same as components doesn't. Yeah. So yeah, we'll carefully maintain the links between nets and junctions. Although other components we do in the future, delay elements, or whether I add like input elements, output elements, like special like thing like lights or LEDs or like thrusters on a spaceship or whatever things that the circuits control, that will just go straight into components and they'll all work pretty much the same way. And they'll just sit in the components list. So I think it's fine to have junctions as a separate list. So let's just put that in. Each net has components list, includes gates and delays. I'll call them registers. And whatever else I add. Each net has a separate list of junctions. We will carefully maintain this link relationship. Yeah, we will just treat it separately. We'll just write code for it and get it done. What changes for DFS when it comes to junctions? Not very much. We basically just need another special case on top of the ones we have for top of the one we have for gates right now. So a new special case for junction DFS. Ultimately, bottom line is this. Any components will merge them into the gate code path. Junctions will pretty much always need their own code path. I'm satisfied with that. All right, what else we got on this list? So I just like brain dumped what I'm thinking about junctions. I can't write any more code today. Like I just can't. Copy and paste. I was thinking about this earlier. Before copy and paste, we actually should do save and load support. This is going to include deserializing tile list into net and component objects. And the reason I need to do this first is because that's actually necessary for when we're pasting. We could, so there's two options. One of them is when we copy, we will do more than just copy essentially the like tile IDs. What we'll do is like, so let's say, so I have my great big array, right? That for every coordinate in the array, it points to one of the net or component or junction objects. And then I select some subarray of it, like say the block starting at index 2, 2, which is 5 blocks wide and 5 blocks tall, say. Now, when I copy that part to another part of the map, say I copy it like 100 blocks to the right or something, or 100 spaces to the right, I can check all the pointers and the metadata and the ports and the neighbors and the whatchamahoots and the whatchamacallits and correctly rebuild all of the data structures, right? And I can do that. Wouldn't be a problem, and I think it's a good solution. Except for the fact that that code that I would write to do that would not handle the deserialization. The whole point of the way I've done this whole design is that when you want to save, you'll just overwrite the map section of the cartridge. And all that will be left is the tile IDs. And I need to deserialize that. So I'll basically be writing very similar code that essentially scans through an array of things and then rebuilds net junction component objects. Except they would be different and incompatible, right? Because in the first copy and paste case where I have access to the whole metadata, I can traverse the pointers and do all that. And that's fine. But like, if instead I can just literally serialize it to tiles and then deserialize it, then I only need to write one function that reads a grid and figures out the objects. It's a little less efficient, but let's not forget, like, copy and paste operates at the speed of a human being entering things. And even for Pico 8, like, who cares if that's slow? Like, if I hit paste and it takes like half a second, fine. No one cares. If it takes more than half a second, I think people will be like a little annoyed. And let's not forget, it's only going to take more time the bigger thing you paste, and people expect that bigger copies and pastes will take more time. So even if if you paste exactly like half the map to the other half, and it takes like 5 seconds, no one's going to bat an eyelid. I mean, think about it. To even draw half a map's worth of stuff and manage it, takes way longer than that. So yeah. Anyway, that big long discussion is to say that I will implement copy and paste as serializing to map tiles and deserializing from it, so that I only have to write one deserialization function, not two slightly different ones, even if serializing and deserializing into map tiles is less efficient. I don't care. Okay, what else do we have on here? That thing about toggling connections from nets to gates. I'm not even sure if I'll do that. It's pretty quick to do. I'll think about that next time. Yeah, here's all the brain dump we just did. Drawing wire between gate and net should, I already have that written down. Need to implement map scrolling. Done and done. We need the ability to slow down sim. Yeah, actually, we should. I'll just put this on the to-do list. That really should be on the to-do list. This is on the to-do list. This is in progress. This is on the to-do list. This is my brain dump. Well, let's just put this on the to-do list. Delay elements. I'll just call them register elements, because they have enabled pins, so that you can like latch values and stuff. Yeah, actually, let's also add this in. Add IO components. I mean, it's a little, normally these things that I add on the to-do list are things that are very, very concrete and don't need any like quote unquote requirements engineering. This one kind of does, but that's okay. Need to deal with adjacent gates junctions. Oh, I already did that. Done. Okay, other stuff. DFS needs to understand how to do the junctions. Yes, but that's already on the list. We need things that circuit controls. I'll leave these in here because, you know, it's related to this, but it'd be cool to have a CPU chip to plug in. That would be cool. I'm not doing that. I'm axing that. Already written down. Oh, the undo stack. Man, we really do need that. Multi-bit plus as an analog. We'll leave these ideas in. Yeah, I'll try and do some song loops or something. Sim loop. I don't really need this anymore. Well, no, let's leave it. Big count that used to be in tab 1. We can leave that for now. Ancient stuff, we can leave that. Okay. Let's go in here. I'm just spending the rest of this time here to try and clean stuff up. Make things a little more friendly for me to work on next time. This is fine. This is a little wonky. Whatever, I'll just leave it. To prevent writing a bunch of extra cases, swap P and C if it lets us use an existing code path. Yeah, this is fine. It's a little weird, but for each of C's cores, edit them in the grid 2.2p. Also add them into P's chord list. Okay. I don't really need these logs anymore, do I? Well, we'll leave them for now. Let's use gates. Make sure that the port pointers are empty. Yeah, we can leave this. This will eventually go away. These two lines will go away at some point. We really don't need this anymore. This is fine. We also don't need this anymore. We'll have to deal with this soon enough. Also, I changed this to be that. Alright, let's clean up this. Why is this so long? Oh, this is where we create a new net, right? Yeah. We could kind of do this all as an inline constructor, which I think would look a little cleaner. It also gives me a chance to write this comment here. This LWL gets used a lot, but that's okay. I think it's fine. Let's just leave it. Yeah, this is fine. Well, I'll leave this, but I'll comment it because I don't really need to see that in the log anymore. Oh, nils. P.neighbor. Oh yeah, this is to delete the port from the components list. Yeah, interesting. Using the same port as in this case covered both. Let's just rewrite this to be a little shorter. Come on. We don't need that anymore. Actually, we'll keep that. I don't really need this anymore, do I? Where is this? This is at the bottom of array square. We can comment it. I don't, I mean, every single time I like erase, like actually delete a debug statement, I need it like 5 minutes later. So, yeah. Let's just make this one line here. Keep things short. Actually, let's just leave that comment. I think it's fine, even if it's long. Actually, yeah, this code already handles junctions. It so happens. That assert covers this log. Yeah, whatever, it's fine. We're not even using this right now. We're not even using this right now. Just get rid of it. We'll have lots of opportunities to add it in later. Did I clean this up yet? This is now OXOY. This doesn't do anything yet, so, but let's leave it because I will add that at some point. Really don't need this. That's already debugged elsewhere. This is ugly, but whatever, it's fine. This is fine. And then, come on. need to clean this up. This is just a safety assertion thing. Okay, fine, good. So none of it clean up. Hopefully it's a little more friendly to work with this code now. At least I did something. Oops. Okay, it's all pushed. This is my cue to stop. If I try to start anything else, I'll just be up too late.